All right, keep getting practice for the last check-in. All right, one of the things you might see mentioned that's a term we don't use a whole lot, but sometimes, or not sometimes, often we definitely forget what it means, is additive inverses, okay? What an additive inverse is it's asking you like two numbers that add up to equal 0. All right, so who can tell me what plus 5 equals 0? Sydney. -5. And then let's look at another one. -7 plus what equals 0? Jeremiah? So basically, additive inverses are numbers and their opposites, okay? So the positive and negative version of the same number. Okay? Everybody clear on that? Yeah. It's not too often you see it, but like I said, if a question asks you about an additive inverse or what's the additive inverse of some number, all it's looking for is the opposite. All right, go ahead and do that one. -9 plus 5. Robert, what you got? -4 is correct. So with addition, when the signs are different, you subtract. So 9 minus 5 gives us 4, and you use the sign of the bigger number. Most of y'all got pretty good at that. So similar idea. Might see some subtraction. Ford?
-1?
Nope. Gray? No. Kyle? Alea?
-7?
Nope. Jeremiah?
It's not that hard.
Mason?
Oh, it was +7. Oh, you got it.
All right, so, yeah, not remembering so much on that one. What do we do for subtracting with negatives? Same change, change. First number stays the same. We change from subtraction to addition, and then we change the sign on the second number. Then we just follow the addition rules. Well, this is just two positive numbers now, so 3 plus 4 gives us 7. Okay? All right, so here is more likely what you're going to see. You're not going to see necessarily a problem like that.
Oh, I remember these.
You're more likely to see these circles. Sometimes they call them like charges or whatever, but like, whatever. They're circles with plus or minus signs to them, okay? So who can tell me what the expression is or what the problem is? Alea?
4 minus -6.
Nope. Close. Sydney?
-7 minus 4.
Nope. Zion?
4 plus -7.
Yeah, so when we've got the circles here, it is an addition problem. Everybody clear on that? These circles, the charge disks, whatever they're called, they are addition problems. You take the number of positives, you add the number of negatives. Everybody clear on that? So it's always going to be an addition problem. The answer then, signs are different. You subtract, sign the bigger number, -3. If you cancel them out, what you got left is -3. Okay? So here's where it gets a little bit different. I'll do this one. So we got 5 positives, 7 negatives, right? And I said it's an addition problem. 5 plus -7. That is not one of the answer choices, is it? So what you have to do on a lot of these is same change, change with subtraction, okay? So if I do same change, change, 5 plus -7, that's what we're looking for. 5 plus +7, right? Everybody see how that works? So that's a lot of times how they make these trickier, is we think of it or we see it, it's a addition problem. If they put subtraction problems in the answer choices, you got to do same change, change to compare them correctly. Okay? Distance works a little bit differently. It follows different rules, doesn't it? So go ahead and find the distance between those 2 points. Y'all in art yesterday, if you made it to number 11, this should look familiar. I think it was 11. Whatever the last one was, I'm pretty sure. Sari? All right, so we don't use the 4s when we're finding the distance. We don't use the matches. With distance, it's different when the signs are different, isn't it? It's not the same as our addition rules, okay? Finding distance is not the same as addition. Everybody's clear on that? So the rules are, when the signs are different, we are going to add the absolute values. So what's the absolute value of 3.5? Or negative 3.5? 3.5. What's the absolute value of 2.5? 2.5. It's just the positive version of each number. So when we add them, 3 plus 2 is 5. Half plus half is 1, so that makes 6, like she said. Okay? You could also change them to improper fractions and do the addition that way. That would obviously work too. Any questions on that one? Just like I said, I wanted to show distance is different. It's not following the same rules as negatives. All right, length of a rectangle is 3 more than twice the width. What equation shows the relationship between the length and the width of the rectangle? So use L and W as your variables. You should either have a L equals or a W equals, okay? Sydney? Nope. Alea? All right, it says the length is, so that's how we get the L equals, okay? 3 more, that's the plus 3. Twice the width is 2W. So 3 more than twice the width means you got 2W plus 3. Okay? Try that without a calculator. Bert the Butcher has 27 pounds of beef. He is going to put the beef equally into 5 packages. How many pounds of beef will be in each package? Brian? 5.4 is correct. So 27 divided by 5 is what we're doing. So we got 27 on the inside, 5 on the outside. Doesn't go into 2, goes into 27 5 times. 5 times 5 is 25. We put a decimal and a 0. 0 comes down. Decimal goes up. 5 goes into 20 4 times. We got no remainder, so that's where we end it. Okay? Shouldn't be a tough problem, but there is a good chance you see stuff like that on the inactive where you got to do some division with some decimals.